Sound is carried in waves, known as sound waves. So, in general, when you're talking about sound, I would say that it's a wave. Sound waves are sound. And what a sound wave is the vibration of objects moving back and forth, carried through compressional and refractional sections of air to some sort of detector like our ear. So, for example, the usual construction of sound could be from our vocal cords, but it's easier to see something like this with a moving piece of material back and forth. So this material vibrates back and forth. And as it goes back and forth, as it pushes forward, it compresses the air. And this is all the compressed air. As it goes backwards, it creates a vacuum, it pulls back on the air, and it creates a pulse backwards. And this is the rarefaction, or the less dense air from the pulse. And so this vibration back and forth creates vibrating air that moves through the air. So this back and forth motion that stays right here in this one place, so the vibration stays in place, but the wave that it creates in the air moves through the air. And if you wanted to see like a translational wave model of this sort of thing, in other words, if you wanted to see the up and down wave versus the back and forth wave that we have right here, then it would look something like this, where you would be peaking at the compressions, dripping into the rarefaction, peaking in the compressions, dripping in the rarefactions. And so this would be something that you would see on an oscilloscope, where it takes the compressional waves that are going through the air that is sound and translates it into an electronic wave that we can see on an oscilloscope. This is what you would be seeing, is the compressions and refractions being turned into crests and troughs of a transverse wave. And we'll look at the definition of transverse and longitudinal in just a couple slides here. But basically, as far as what sound's concerned, we're looking at a vibration that creates a wave through the air that is then detected by the ear or some other detector, like a microphone, receiver, some sort of electronic device. And this is what a sound is. Basically, sound is the motion of the air created by vibrating objects. So, can you hear things in space? Would you expect that you would be able to hear an explosion in space? If you were out in the middle of space and a satellite exploded and there was nothing between you but space, you and the satellite, would you be able to hear it? No, and you shouldn't be able to hear it because you need material for the sound to pass through. So this whole explanation of sound has required air, but it's not just air that you need, but what we call medium.